Myself, Dr. Naresh Kumar, Associate Professor, Department of Mathematics, Institute of Aeronautical Engineering, Dundigal, Hyderabad. Today, I want to discuss some problems on case 9. This case we have already discussed in last lectures. But now we want to solve clearly some problem on case 9. So today I am taking this topic: if q is equal to x to the power n into sin ax or x to the power n into cos ax. These two functions are involved in case 9. There are multiplication of two functions, algebraic function and trigonometrical function. But in trigonometrical function, there are only two functions are allowed, sin ax and cos ax. No other functions are allowed here. Tan ax, cosec ax, cot ax and sec ax. These four functions are not allowed here with algebraic function. With algebraic function, there are only two functions are allowed, sin ax and cos ax. So basically, in case 9, we find out particular integral if q is x to the power n into sin ax or x to the power n into cos ax. So in q, there are two functions, both are in multiply. First is algebraic function, other is trigonometrical function. So we want to solve here problem in detail. In case 9, in this case, I want to discuss about the solution of some standard function of q is equal to x to the power n into sin ax. Here, the value of q is x to the power n into sin ax, x to the power n into sin ax, and x to the power n into cos ax. Only these two functions are allowed in case 9. N is number. N is any positive number. Suppose x, x square, x cube. And sin ax. In sin ax and cos ax, a is also number. Sin 2x, sin x, sin 3x, and any number may be there. So these functions q is given in differential equation with constant coefficient. These two functions are given in differential equation with constant coefficient are given as follows. Here I am writing some differential equation, general differential equation, general differential equation I am writing here. So what is the general differential equation? d2y over dx2 plus p1 dy over dx plus p2 y is equal to x to the power n and cos ax. This is equation 1. Next equation, d2y over dx2 plus p1 dy dx and plus p2 y is equal to x to the power n sin ax. This is equation 2. So basically here this equation 1, this is general equation. This is equation 2, this is general equation. Our question depend on these equation 1 and 2. In one equation, algebraic function here common. Algebraic function is common here. But in one equation is cos ax, other equation is sin ax. So here we want to solve only two problems on case 9. One is depend on cos ax and other is depend on sin ax. So one by one we discuss here problem in detail. Now follows problem based on case 9 here. We discuss here following problem based on case 9 which we want to solve here. Okay. These problems depend on case 9. So now problem 1 based on case 9. This problem is d2y over dx2 minus 2dy dx plus y is equal to x sin x. So this is same problem. This function is as follows here, x to the power n sin ax. What here is given? X sin x. So here n is 1 and a is also 1. Comparing this function. This q is general function. This q is given function. This is given in our question. This is general function. This function is q is general function. This function is given in our question. So how we can say that this differential equation is known as a linear differential equation with constant coefficient? So we have discussed several times this equation in last lecture. Here is number 1 multiply. Here is number 2 multiply. Here is number 1 multiply. So in left hand side, there is multiplication with derivative are constant. So this linear differential equation is known as a second order with constant coefficient. And on right hand side, there is some function of q. But in case 9, we have taken the function, type of function is x to the power n sin ax. So here x to the power n is 1 here. Sin ax, here is sin x, so a is also 1 here. And problem 2, which want to solve in this case 9, based on case 9. I am taking here two problem. I am writing in starting of the two problem. In this lecture, we want to solve these problem 1 and problem 2 in detail. Then case 9 is complete. And one problem we have already solved in last lecture on case 9. So this case completely covered. Next problem 2 based on case 9, d4y over dx4. This is fourth order differential equation. Fourth order linear differential equation of fourth order with constant coefficient. This equation may be of n order, 2 order, 3 order, 4 order, 5 order, more than 1 order. Minimum order is 2. Maximum order is n. Then we can solve linear differential equation of nth order with constant coefficient. But n is any number, 2 number, 3 number, 4 number, second order, third order, fourth order. So this is differential equation of fourth order with constant coefficient. But right hand side q is x square cos x. This depend on function x to the power n cos ax. Here is function given x square and cos x. So here n is 2 and a is 1. In second problem, the value of n is 2 and a is 1. These problems 1 and 2 are known as a linear differential equation with constant coefficient. So now, first we want to discuss problem 1 in detail. Problem 1 based on case 9. So solve d2y over dx2 minus 2dy dx plus y equal to x sin x. This is question which is given in our question paper. We want to solve this question. Then we start the solution. And writing the question first here. This is question which is given in our question paper. After writing solution, we write the question and taking this equation 1. Okay. So now equation 1 can be written as, this is D form equation. How we can write D form? d2y over dx2. This equal to d square y. dy over dx. This is dy. So now question is d2y over dx2 minus 2 dy over dx and plus 1 y. Okay, this equal to x sin x. So now here y is common, this is d square minus this is 2d and this 1 y is common here. This equal to x sin x. So we can write this equation is this y taking common to right hand side. This y taking common, this differentiate y. Here is also y differentiate. So y taking common at right hand side of the equation. Then equation 1 can be written as this equation 2. This is D form equation. This is function of d here. Function of d into function of x equal to x sin x. Function of d means function in derivative form. D is here derivative. So this function is known as a derivative form function. D square minus 2d plus 1y equal to x sin x. This is same equation 2. Where this is fd. Fd into y is equal to q. Where q is x sin x. This is equation 3. Our main equation, main differential equation is in type. What is type? This is f dy is equal to q. This is type of differential equation. F dy is equal to q. Main our question is this type. Function of d, y is function of x equal to q function of x. So solution of equation 2 in two part because q is given here. The problem 1, in problem 1 q is given here. So the solution of problem 1 is in two part. We find two solution of problem 1. First solution is complementary function, second solution is PI, particular integral. So now here first we find out complementary function. To find complementary function, what we are doing to find function? So to find complementary function, put it q equal to 0. Here q is x sin x. So x sin x taking 0. This is q. Q equal to putting x sin x equal to 0. Means right hand side is 0. In equation 2, then we get here. So d square minus 2d plus 1y is equal to q. This equation 5 equal to 0. Here q is 0. Putting here q is 0. So this equation is 5. Because we want to CF of equation 5. Now in equation 5 putting d equal to m and removing y from 5. Then we get an auxiliary form of 5. D equal to m. Here putting d equal to m here and removing y. This y is removing from equation 5. Then we get an auxiliary form in variable m. So here m square minus 2m plus 1 equal to 0. This is equation 6. Now factorizing equation 6, finding value of m. Value of m or roots of m. Roots of m. We can say value of m or roots of m. So m square minus 2m plus 1 equal to 0. This is depend on given formula. This equation, this is auxiliary equation, m square minus 2m plus 1 equal to 0. This is depend on given formula, given identity. What is identity? A square minus 2ab plus b square. So this is known as a minus b ka whole square. Here a is here. Here a is m and b is 1. After comparing here, putting here a is m, b is 1. So m square minus 2m, b is 1 plus 1. Then we get the factorizing of equation 6. Then we can write according to m identity. Then we get factorizing of equation 6. So m minus 1 ka whole square equal to 0. M minus 1 ka whole square means this bracket writing 2 times. M minus 1 into m minus 1 equal to 0. Because this is quadratic equation. Perfect square here. Perfect square have same roots. B square minus 4ac is 0 here. In Sridharacharya formula. then we get same roots. So here if m minus 1 is 0, then m is 1. And again if m minus 1 is 0, then m is 1. Here we get roots of an auxiliary form 6, m equal to 1, 1. Here we get m equal to 1 and 1 roots. Here roots of an auxiliary form, we see that roots of an auxiliary form are equal. So we apply here formula for equal roots. We have discussed this formula several times. So here direct apply formula. This is very easy formula. CF is equal to C1 plus C2x e to the power mx. M is roots. M is here 1. This is formula for equal roots. If roots are equal, 2 times equal roots, then we write this formula. So putting value of m here. So this equal to CF is equal to here, CF is equal to C1 plus C2 e to the power C2x and e to the power x. This is answer. This is complete CF, complementary function of given problem 1. Here finding second part of the solution, that is PI, particular integral. Here we will discuss case 9. What is case 9 in particular integral? What we are doing in case 9 to find the particular integral? So here if q is x to the power n cos ax or x to the power n sin ax, these two conditions only, not other any result allowed here. X to the power n cos ax, x to the power n sin ax. So particular integral equal to 1 upon fd into q. This is basic formula. 1 upon pi is equal to here formula 1 upon fd and into q. This is formula. So we apply this formula here. Fd, q is this here, x to the power n cos ax or x to the power n sin ax. This or this may be any problem here. Then what will be happen here? We use here formula of pi. So pi equal to 1 upon fdq, 1 upon fdx to the power n sin vx. This is equation 9. So here sin vx, this is trigonometrical function sin vx. In place of sin vx, writing e to the power ivx. Ip of e to the power ivx. Sin vx, any place is sin vx equal to writing ip of imaginary part of e to the power ivx. Because e to the power ivx is equal to cos bx plus I sin bx. So this is imaginary part of this function. This imaginary part is sin bx. So I am writing this here. Imaginary part e to the power ivx x to the power n. Because ip of e to the power ivx sin bx. So here this e to the power ivx taking left side. Exponential function here taking left side. Then this is ip of e to the power ivx putting d plus iv. iv is here number in sign. iv into x to the power n. This is equation 10. Same this formula we apply in our question. Same this process apply in our question in problem 1. Problem 1 to find pi, particular integral. Same this process apply in problem 1 to find particular integral. So now here, similarly this formula 10 apply in problem 1. 10 is this last formula. This is 10. Equation 10 this. This formula apply in our question. So pi is equal to 1 upon fdq equal to 1 upon, this is fd. This is function in d form. And q x sin x. X sin x is given in our question. This is value of q. Q is here x sin x. I am writing several times x sin x. Q is given here x sin x. X sin x. X sin x. So same process which we discussed in equation number 10, that is apply in 11 number, because that is general procedure. For general Q, we apply in equation 10. Q is general function, so we apply general procedure. Same procedure given in our question, because here all value is known. There is x to the power n is unknown, n is number, n is unknown. Sin x, a is unknown number. But here is n is 1 and a is 1 here. In our question, a is 1. A is 1, n is 1. So this question, this is known as a problem. So now here, this is d minus 1 ka whole square. This is perfect square. So I am writing d minus 1 ka whole square into x. And in place of sin x, I am writing ip of e to the power ix. Imaginary part of e to the power ix is sin x. ip of, I am here discuss this, ip of e to the power ix is equal to ip of e to the power ix, formula of e to the power ix cos x plus I sin x. So ip of this function, ip means imaginary part. Here this is real part. This is imaginary part. So imaginary part of this result is sin x. So in place of sin x, I am writing ip of e to the power ix. Because e to the power ix is cos x plus I sin x. So here writing ip of, this ip of taking left side here. ip of writing is starting of pi. So pi is equal to ip of 1 upon d minus 1 ka whole square into x e to the power x. X e to the power ix. This equation 30. Now here in our question given two function. First is algebraic, other is trigonometrical. But after apply complex number here, then we see that here x e to the power ix. In equation 13, there is first function is algebraic, other function is exponential. And when we see that in last problems, if there are two functions, one is algebraic, other is exponential. Then exponential function taking left side, suppose exponential function is e to the power ax. So e to the power ax taking left side and putting d equal to d plus a. This is basic formula. I am discussing last problems. So here we taking e to the power ix, this is exponential function. This function taking left side in multiply and putting d equal to d plus I. So now here ip of e to the power ix taking left side of the pi in multiply and 1 upon putting d equal to d plus I minus 1 ka whole square into x. There is only single variable is x. Exponential function goes to left side in multiply of pi. This is equation 13. Now ip of e to the power ix and here making binomial. Here making binomial. So what is binomial? Binomial is 1 plus x to the power n. This is binomial. So first term is 1, other term is x. So here we making here 1. It means I minus 1 taking common. Because lowest power of b, here taking lowest power of b is common. In equation 13, lowest power is I minus 1 into d to the power 0. So I minus 1 is taking common. Then we get here 1. And I minus goes to d upon I minus 1. So I minus 1. But here whole square. Whole square it means I minus 1 ka whole square taking common. So I minus 1 ka whole square into 1 upon 1 plus d upon I minus 1 ka whole square into x. This is equation 40. Now this 1 plus this x. X is here d upon I minus 1. This. So here 1 plus x to the power square. Making binomial, taking numerator. So this writing this is in denominator. This function is denominator. This writing in numerator. So we write here 1 plus d upon I minus 1 to power minus 2. This is x here function. So expanding y binomial to equation 15. Binomial function is this 1 plus x to the power n. So this 1 plus nx plus n into n minus 1 upon factorial 2 into x square plus n into n minus 1 into n minus 2 and x cube upon factorial 3 and plus this 3. This is known as a binomial formula. So we have discussed here binomial formula 1 plus x to the power n. This equal to 1 plus nx plus n minus 1 upon 2x square n minus 1 n minus 2x square upon 3. Last term is n. If n is positive, then this is last term is x to the power n. If n is positive, then last is x to the power n. If n is negative, then this goes to infinity. Last term is infinity. N is negative, then infinity last term. N is positive, then last term x to the power n. So comparing in equation 15 and 16, then we get value of n is minus 2. Value of n is minus 2 and x is d upon I minus 1. These value putting in our binomial formula 16 formula. Then we get here particular integral equal to ip of e to the power ix 1 upon I minus 1 ka square. Here 1 plus minus 2, 1 plus n into x, nx, 1 plus nx, n into x, plus n minus 2, n minus 1, minus 2 minus 1 upon factorial 2 into x square, d upon I minus 1 ka whole square, and plus this x 16 and whole cube, whole 4 and so on. So now here particular integral ip of e to the power ix 1 upon I minus 1 ka whole square. Now multiply here, this is x function here. So x taking inside the bracket. When x goes to inside the bracket, what will be happen here? Here is dx. Here is 1 into x. Here is d square into x. And next term d cube into x, d4 into x. This is infinite series. So what will be happen when multiply by x? We get here x, here dx, here d square x. And next d cube x. Next term is d cube x. Then d4x. And these are our terms we get here. So now ip of e to the power ix whole square, open this whole square, I square plus 1 minus 2i. And x minus 2 dx upon I minus 1 plus 3 d square x upon I square. Open this whole square, I square plus 1 minus 2i. I minus 1 ka whole square. This is I square plus 1 minus 2i. I square is minus 1 plus 1 minus 2i. This 1 cancel. So this is 2i here. Okay. So now we know that here I square is minus 1, putting in above equation. Then we get here. Then we get here. So pi is equal to ip of e to the power ix. Now here 1 upon it. This I square. I square is minus 1 here. I square, this is minus 1 here. So in place of I square putting minus 1. In our problem here 17. So here is minus 1 plus 1 minus 2i. X minus 2 dx I minus 1 plus 3. We get, how we get 3 here? Solving this minus 2 minus 2 minus 1. 2, 3, 2 just 6 upon 2. Factorial 2 is 2. So this is 3 here basically. This is plus, minus, plus. So now here, this 1 is cancel and this 1 is cancel. So pi equal to ip of e to the power ix 1 upon minus 2i x minus 2 dx upon I minus 1 and plus 3 d square x upon minus 2i plus other terms are 0. Other terms are and other terms. Now we know that here dx is 1. dx is 1. d over dx of x is 1. And d2 over dx2 of x is 0. 2 time differential. 3 time differential d3 over dx3 is x is 0. 3 time differential 0. So here d cube x 0. d4 x 0. d and d to the power n x is 0. So now here pi is equal to ip of e to the power ix 1 upon minus 2i square. 2i square. How we can get here I square? Multiply I in numerator and I in denominator, taking its conjugate. I multiply I, so I square. Numerator I and denominator I here in this result. So we get I into I square. I square is minus 1. So we get here minus 1. X minus 2 multiply in this function. Conjugate of I minus 1. I plus 1. I plus 1 in numerator and I plus 1 in denominator. Okay. And d square x is 0 and dx is 1 here. So dx is here 1 and d square x is 0. This is, we know that dx is 1, t square x is 0, t cube x is 0, dn x is 0. And is any number more than 1. Then the derivative of this result always be 0. So pi equal to ip of I upon minus 2i square x minus 2. I plus 1. This I minus 1, I plus 1. Here formula a square minus b square is in here. So this is I square minus 1. In numerator I plus 1. And this term is 0. Only 2 terms are there remaining. Other terms are 0. Higher terms all are 0. So pi equal to ip of e to the power ix. Here I upon minus 2i square x minus 2. I plus 1. Here I square minus 1. So now pi equal to ip of e to the power ix. I upon minus 2i square is minus 1. X minus 2. I plus 1. This minus 1 minus 1. I square is minus 1 and minus 1. Minus 1 minus 1. So now here pi equal to ip of e to the power ix. I upon 2 here. How we get here 2? Minus 2 plus minus 1. Minus 1 plus 2 into 1, 2. And here minus 2. Minus 2 minus 2. 2, 2 is cancelled here. Now next. 2, 2. 2, 2 is cancelled here. Minus minus plus here. So here I plus 1. And 2, 2 cancel plus. X plus I plus 1. Here I by 2. IP of here e to the power ix. Value of e to the power ix I am writing here cos x and plus I sin x. This is the value. So I am putting here this value cos x plus I sin x and multiply this I in bracket. Here I multiply in this bracket. Total bracket. So ix plus I into I square plus I. Again putting I square is minus 1. So IP of this function cos x plus I sin x 1 upon 2 ix minus 1 plus I. Now I is common here. So I is common here x plus 1. X plus 1 here minus 1. So now P taking here imaginary part. Taking imaginary part. Imaginary part only imaginary part because in our question is sin x. So here taking imaginary part. Imaginary part, when we get imaginary part, real part multiply by imaginary. In first bracket real function multiply imaginary function. Then we get imaginary part. And imaginary part multiply by real function. Then we get imaginary part. Both conditions. Real to imaginary, imaginary to real. In both conditions we get imaginary part. So here cos x is real. Cos x is real. Ix plus 1 is imaginary. So this multiply to this. So we get 1 upon 2x plus 1 cos x. And I sin x is imaginary. And minus 1 is real. So minus I sin x. We get here x plus 1 and 1 upon 2 is there. 1 upon 2 is common. So here is 1 upon 2. 1 upon 2 here. 1 upon 2. X plus 1 cos x minus sin x. This is complete PI. This is complete PI of problem 1. Of problem 1. Complete PI of problem 1. Problem 1. Complete PI of problem 1. Okay. Now complete solution of problem 1 of 1. 1 means problem 1 or equation 1 is y equal to CF plus PI. So now y is equal to, this is complementary function, this is PI. So this PI is here into 1 upon 2 and this x plus 1. This is complete PI. C1 plus C2x e to the power x and plus x plus 1 cos x minus sin x into 1 upon 2. We write here this plus 1 and here 1 upon 2. This is cancelled. Okay. So this is complete PI. CF plus PI. Now problem 1 is complete in detail. Every topic we discussed here in detail problem 1. Now similarly, we solving problem 2. Problem 2 based on case 9. So solving here, solve d4y over dx4 plus 2d2y over dx2 plus y. This is fourth order differential equation. Fourth order differential equation. Fourth order with constant coefficient. With constant coefficient. This equation fourth order differential equation with constant coefficient. Okay, this is more than two order, more than three order. This is fourth order linear differential equation with constant coefficient. In left hand side is number in multiply. Here is one number, here is two number, here is one number. And right hand side q is x square cos x. Q equal to, we have taken x to the power n and cos x. But this equal to x square cos x. So here n is here. So here n is 1, n is 2 and a is 1. ये cos x. A is 1 here. Solution. Start solution of problem 2. First of all, I am writing same question in solution from the question paper. So d4y over dx4 plus 2d square y over dx square plus y equal to x square cos x. This is equation 1. Now equation 1 can be written in D form. Written as in D form. D form. D form. D form means function of D means function of D. Function of D. Function of D. D form means function of D. So this equation is d4 plus 2d square plus 1y equal to x square plus x. This is equation 2. Now, our general equation is this type. F dy. General equation is F dy is equal to q. This is general differential equation. F d function of d, y and q. Y and q both are function of x. So here q equal to x sin x given in our question. In first problem, x sin x. Q is given here x square and cos x. Not this. X square and cos x. So now, where f d equal to this is function of d in equation 4, f d form. This is d form function. Function d. Solution of equation 2 in two parts because q is given here. In our question, q is given, so we find out the solution in two parts. First part is complementary function, second part is particular integral. So first solution is CF and second solution is particular integral. Now here first we will find CF. To find complementary function, put it q equal to 0 in equation 2. Then we get means q equal to x square cos x and x square cos x taking 0 here. This is right hand side. This is right hand side. RHS. RHS must be 0 to find the complementary function. So here this is d की power 4 plus 2d square plus 1 y equal to 0. This equation number 5. This equation 5. So now in 5 putting d equal to m and removing y from equation 5. To find from in equation 5 we find an algebraic equation. We find an algebraic equation. So find auxiliary equation. We find an auxiliary equation. So putting d equal to m and y removing from 5. Then we get an auxiliary form of 5. So putting d equal to m, here putting d equal to m, d equal to putting m and y remove from 5, y remove from 5. Then we get m4 plus 2m square plus 1 equal to 0. This equation 6. This is same perfect square. This equation 6, this is same perfect square. Here is m4 plus 2m square and plus 1. This equal to 0. I am writing here a4 plus 2a square b square and plus b square, b की power 4. This equal to 0. This is a square plus b square का whole square. So here a square is m square. A is m here and b is 1. A is m here and b is 1 putting here. So m square plus 1 का whole square. This is depend on given formula a square minus 2ab plus b square. A minus b का whole square. We can write according above identity. Then we get factorizing of 6. So now here m square plus 1 का whole square. Whole square means repeated time. 2 times repeated. Same repeated. As x square. This is x into x. Okay. Into. This is x into. Similarly, m square into m square plus 1. M square plus 1 into m square plus 1 equal to 0. There are 2 factors. Both are same. Both are same. Both are same. Same factor. If m square plus 1 equal to 0, then m square equal to minus 1. This 1 goes to this side. Then m square is minus 1. What we know that I square is minus 1 here. I square minus 1 means m square is minus. This is I square. This is minus 1. Minus 1 is I square. So m equal to here plus minus I. Here I am writing formula m square minus I square equal to 0. So m plus I and m minus I. So here is 2 formula m equal to I and minus I. So m equal to here plus minus I. Okay. So here is m equal to plus minus I. Similarly for second factor we get same roots m equal to plus minus I. So we have here same repeated imaginary roots. Repeated imaginary roots. So here is different formula to find complementary function. We have different formula. So here m equal to one roots is plus minus I and m equal to other root is plus minus I. So roots are repeated roots 2 times. Roots repeated 2 times. 2 times roots are repeated. 2 times roots are repeated here. So now formula for complementary function, repeated imaginary roots. This is I am writing formula, general formula of repeated roots. E to the power alpha x C1 plus C2x. This is repeated roots formula. We have applied in several times. C1 plus C2x. Here is imaginary formula cos beta x plus C3 plus C4x sin beta x. This is special formula. So now complementary function, putting here alpha is 0 and beta is 1. So now C1 plus C2 e to the power alpha is 0, so this is 1. C1 plus C2x cos x plus C3 plus C4x sin x. This is complete complementary function. Equation number 8 is complete complementary function of problem 1. Similarly, this formula 10 from problem 1 apply in problem 2. I have discussed in equation 10 in problem 1 in detail. So same procedure apply in problem 2. So we are applying here same problem. Procedure we have given in equation number 10. So same procedure we apply in problem 2. So particular integral here pi is equal to 1 upon fd into q equal to, putting here value of fd. Fd is d4 plus 2d square plus 1. This is x square cos x. X square cos x is q. Q is given here x square cos x in our question. So how we can find particular integral when x square cos x is given? But we have discussed a general problem. Q is x to the power n into cos ax. Cos ax. This problem, general problem this. But in our question is this problem. So now we know that Rp of e to the power ix. In our question is given cos x. Cos x is given here. So cos x is real part. Real part is cos x. Real part is cos x. And imaginary part is sin x. Imaginary part is sin x. Real part is cos x. So we know that Rp means real part of e to the power ix is cos x. Because e to the power ix is cos x plus I sin x. Here in with sin x I multiply. Cos x is no I. So cos x is real part. Sin x is imaginary part. So now particular integral pi equal to 1 upon d4 plus 2d square plus 1 into x square. I am putting this value of cos x. Cos x is Rp of e to the power ix is cos x. So in place of cos x we can put Rp of e to the power ix. Rp of e to the power ix here. So Rp of taking left side. Rp of taking left side here. Rp of 1 upon. This is perfect square. D की power 4 plus here d to the power 4 plus 2d square plus 1. This is d square plus 1 का whole square. A square d to the power 4 plus b square plus 1 plus twice of multiple of 1 and 2. 2d square. So we get same this result. So this is the perfect square here. So d square plus 1 का whole square x square. This is e to the power ix same here. This Rp of taking left side. Again we get here in Q. There are two functions. First is algebraic x square. Second is exponential function. E to the power ix. When there are two functions in Q, first is algebraic, other is exponential function. So exponential function taking left side in multiply of pi and putting d equal to t plus a. Here is e to the power ix. E to the power ix. This is comparison with e to the power ax. So a is I here. So putting d equal to d plus a means putting d equal to d plus I. So now this exponential here we know that q is x square e to the power ix. Then e to the power ix taking to the left side of pi in multiply and putting d equal to d plus I. So now particular integral is Rp of e to the power ix 1 upon this ix taking left side, exponential function taking left side and putting d equal to d plus I. Here is d square plus 1 ka whole square. So d equal to d plus I का square plus 1 का whole square into x square. Pi is equal to Rp of e to the power ix 1 upon opening this whole square d square plus I square plus 2di. Here apply a plus b का whole square, a square plus b square plus 2ab. So a square means d square, b square plus I square and plus 2ab 2di here and plus 1 x square. What I square is minus 1. We know that I square is minus 1 here. So putting I square is minus 1. This is I square. So putting here I square is minus 1. This is minus 1. And this one is cancel here. So here Rp of e to the power ix 1 upon d square plus 2di का whole square into x square. Okay. In denominator of pi taking lowest power of d taking common. Lowest power of d. This is d square, this is d. So lowest power is this d to the power 1. Lowest power of d taking common, i.e. 2di taking common. In this line, in this step, minimum power 2di taking common because we are making here binomial. Binomial is 1 plus x to the power n. This is binomial. I am discussed several times. 1 plus nx plus n minus 1 n into x square upon factorial 2 n plus n into n minus 1 n minus 2 upon factorial 3 into x cube and plus this. This is binomial formula we apply here. So in binomial formula, first term is 1, other term is x. So making 1, we taking this common. 2di taking common. Then there is 1 and d square upon 2di. D square y 2di. 1 plus d square y 2di का whole square. So I am writing here this pi. Particular integral Rp of e to the power ix 1 upon 2di का whole square common. 2di का whole square taking common. Because here is square. Here is square. This is whole square. If we taking 2di common, then square taking common. 2di का whole square. Here 2di का whole square taking common. So this is 4d square and I square. And I square is minus 1 here. So minus 4d square here. So we write here minus 4d square. Okay. And 1 plus d upon d square upon 2di. D square. So 1d is cancel here. We get here d upon 2i only. So d upon 2i का whole square. This is binomial form. But this is in denominator. This function is in denominator. We write in numerator this function. After writing this function in numerator, power is negative. So we get here this next Rp of minus sign, this minus sign taking here Rp of e to the power ix and 1 plus d upon 2i to the power minus 2 upon 4d square. Minus sign taking first here, starting minus. Here only 4d square. This is in denominator 4d square. This function in numerator, power is negative. This is function is x square here. Okay. So now here this is minus Rp of e to the power ix opening this function upon 4d square and opening this function here. 1 minus. Here 1 minus minus 2. 1 minus 2 here. 1 plus minus 2 here. D upon 2i and plus into di and plus minus 2 into minus 2 minus 1 and upon factorial 2 into d square upon 4i square and plus this. This is open this. And here is x square function. Okay. Same formula. This is binomial. This is binomial formula. This is binomial formula. Binomial formula. Okay. So now pi is equal to minus Rp of e to the power ix upon 4dr. Same formula we write here. 1 minus 2 d upon 2i plus minus 2 minus 2 minus 1 upon factorial 2 d square upon 4d square I square. 4 upon 2i का square. What is here? Upon upon is here 2i. Any 4 square, 4 into I square. So 4i square is minus 1 and into x square. D cube, I am writing here D cube. D cube upon this. What D cube is 0. D cube x square is 0 here. And D4 x square is 0 here. So I am not writing this function. D cube, D4, these vanish directly. So here 4D square. Multiplying by x square in bracket. Then this x square differentiate. Then x square differentiate. Multiply by x square in bracket, then x square, function x square is differentiate. So particular integral is minus rp of e to the power ix, here 1 minus 2, here is d only, d differentiation of x square one time upon 2i, and plus minus 2 minus 1 upon factorial 2, d square x square. आगे d cube x cube here, d cube x cube. So this is not x square here. D cube x cube. But d cube x cube is 0. Plus d4 x4 is 0. X square is 0. So this term is 0 here. So only this function open only here. 1, 2, 3. There are 3 functions. What we know that here d of x square is 2x. Differentiation of x square is 2x. D over dx of x square is 2x. This is formula. Okay. So here d square x square is 2. This is 2 only, not 2x. This is 2. D cube x cube is 0. Dn x square is d here square. D cube x square is 0. Dn x square is 0. So here pi equal to minus rp of e to the power x upon 4d square. 1 minus 2. Here d square 2x. 2 is cancel this. This 2 is cancel. The 2x upon I. Minus 2. This factorial 2 cancel. Here is plus 3. Here is 3. 2 is cancel this. This 2. This cancel this 2. Minus 3 plus 3 here. 3. This 2 cancel to this. Minus plus 3. So here is minus 4. So now here next. Minus 2 here. And here is minus 4. So this 2 cancel this 2. This is plus 3. Or this 2 just this 2. So here what happened here? Minus 3 by 2. Minus plus and minus. This is minus 3 by 2. Okay. This is minus 4. This 2 cancel this 2. And this 2 cancel this 2. So this minus plus and minus 3 by 2. So now here 1 plus 2xi upon minus this plus here minus plus. So this plus and minus 3 by 2. There is minus sign. Minus sign is there. Upon d square 4 taken here is d square. Now minus 1 by 4 rp of e to the power ix. Here 1 upon d square. Here is 1 upon d square. 1 upon d square we can write here 1 upon d into 1 upon d. 2 times. This is 2 time integration. So now here 1 upon d and 1 upon d. Here 1 plus 2xi minus this one here. Minus sign. This equation 11. Now we know that 1 upon d function fx. Then integration fx dx. 1 upon d means integration of function fx. Any function given after 1 upon d. 1 upon d fx. Here is 1 upon d. This function is given. So now here pi equal to minus 1 by 4 rp of e to the power ix. 1 upon d. And 1 upon d goes to integration. 1 upon d I am writing integration. And function is this 1 plus 2xi minus 3 by 2. This equation 13. So now here minus 1 by 4 rp of e to the power ix 1 upon d remaining 1 upon d. Here is 1 upon d square. So 1 upon d is this 1 upon d, writing as integration. So here 1 dx plus 2xi dx minus 3 by 2 dx. So here is 1 integration of 1 is x and 2 integration of x is x square by 2 into I plus here 3 by 2x. This is minus sign this. Okay. So now next here again apply formula for equation 12 and equation 14. Again integrating 14. Again apply formula from equation 12. जो भी equation 12 we have applied formula in 12. Again apply formula in 14. 12 which formula apply in 12? In 12 is this. This formula apply in 12. Okay. Again formula apply 12 in 11. Same formula apply in 14. So again apply in 14 means minus 1 by 4 Rp of e to the power Ix. Integration here. Here is given 1 upon d. This 1 upon d. 1 upon d is integration. So here is integration. Function is here. X function. 2 cancel here. X square I. 3 by 2x. So here is x function. 2 cancel here. X square I. And 3 by 2x dx. So x dx. And here 2 is cancel here. Ix square dx and 3 by 2. Here is minus sign. This is minus sign both. 3 by 2 dx here. So now here minus 1 by 4 Rp of e to the power Ix. Here x dx. X dx x square by 2. Here is plus x square by 2. X square by 2. And here is x की power cube by 3. Ix की power cube by 3. And here is minus 3 by 2. X square by 2. X square by 2 here. So x square by 2 means 5 कैसे x square by 2. So 3 by 4. Okay, squared कर दिया. यहाँ आया 3. This is minus x square by 2. Correct लिख गया. I am solving here this problem. Pi is equal to minus 1 by 4 Rp of e to the power Ix integrating this function. This x square by 2 and plus I. 2 is cancel here. And integration x cube by 3 and minus 3 by 2 into x square by 2. Okay. So now this function taking common here. X square by 2 common. So here is x square by 2 common here. So 1 minus 3 by 2, 4. 4 minus 3 by 4, 1 by 4. So here is x square by 8. Here is x square by 2 into 1 by 4. So x square by 8. So now finally here x square by 8. X square by 8 and Ix cube by 3. Clear? This is equation 16. X cube by 8. Now 1 by 4 Rp of cos x. This is value of e to the power Ix. This is the value of e to the power Ix. Open this cos x plus I sin x. And Ix cube by 3 plus x की power 4 by 8. So comparing here, taking real part. Here taking real part. Real part. After multiplying both bracket. Taking real part. Okay. So real part, this is cos x real. And x square by 8 is real. So real multiply real. So this is not 5 here. X square by 8 cos x. And this imaginary multiply real. So this is I square minus x cube by 3 sin x. Okay. So here now this equal to here multiply minus 8 3 ja 24. 24 4 ja 96. So this is 96. Now in bracket. Here is x square. 8 3 are 24 LCM here. 24 means 3x square. 3x square here. 3x square cos x. And minus 8x cube sin x. Sin x. Okay. Minus 1 by upon 96. So this is pi. Minus taking inside the bracket. So here 96. Here 8x cube. 8x cube. This sign is positive. Minus sign is positive. 8x cube sin x or minus 3x square cos x. Here is 3. 3x square cos x. So this is complete pi. This is complete pi. Okay. Now complete solution of 1 is y is equal to CF plus pi. So pi equal to this is CF. Here is CF this and this pi. So pi here is 96. 96 and here is 8x cube sin x and here is 3x square cos x. So this is complete pi. Complete solution of 1. This is complete solution of problem 1. Problem 1. Okay. So now here, thank you.
Like, share and subscribe. Hit the bell icon for more updates.